Hello everyone, welcome back to my YouTube channel, and today we are going to see class 8 science chapter number 5 inside the atom, and this is the third session we are in. Two sessions already we have completed. In that we have studied about the different atomic structure, the research work by the different scientists, and after that we discussed about the electrons, protons, neutrons, atomic structures, electronic configuration. Already we have done these things in the previous sessions. Today is the third session and we are going to discuss in this about the valency and the electronic configuration. Electronic configuration, already we have discussed how the electrons are distributed among the different shells, shell K, shell M, like that we have the different shells. Starting from the K, L, M, N, the number of electrons, the maximum number of electrons what they can hold is nothing but the 2, 8, 18, 32 and so on. When we discuss about this particular electronic configuration, then as we know that electrons are distributed, then the last shell, the number of electron, whatever is present, that helps in identifying or calculating the valency for the particular atom. Maybe a shortage of electron or the excess of electron in the outermost shell brings the concept of a valency. When we talk about the various compounds, how many compounds are possible for a particular atom, what will be the molecular formula of that compound, is all decided by the valency of that particular atom. So to discuss that valency, before that we should know about the skeleton of electronic configuration. Hydrogen is designed, you can see here the nucleus of hydrogen at the center, and the one electron is revolving in the orbit. Only one shell is there. Helium, one shell and the two electron, one is here and one is here. Two electron, they are revolving in a first orbit. Carbon's electronic configuration, if you remember, we had the 2, 4. So first shell is having 2 electron, and then the outermost is having 1, 2, 3 and 4. Same way for the neon, if we are talking about 2 and 8. Sodium 2, 8, 1. These are the electronic configuration we have, and this way we can design and draw the atomic structure. Further, when we talk about this atomic structure, this atomic structures, in this, if we will go back to the sodium, you can see here for the sodium, if I am talking about 2, 8, 1. So that number of electron in the outermost shell is nothing but called as valence electron. They are called as a valence electron. You can see here they have given also valence electron. It can be seen that the valency of an atom is related to the number of valence electron in that atom. And these elements are chemically inert. Which one is inert? The gaseous elements do not combine with any other atom like a helium, neon, where the outermost shell is complete. Like if I am talking about neon, neon's outermost orbit is complete. 8 electrons are needed and it's having a 8 because neon's electronic configuration is a 2, 8. You can see here the second shell maximum electrons are allowed is 8 and it's having 8. So it's complete. So here if the elements are having a completed outermost orbit, they are called as inert elements, or they are chemically inert. They are not forming any bond or the chemical bond with the other atom to make a different molecules. They are separate, and that's why their valency is a 0. and others where it is not complete, their atom tries to make it as a duplet or octet. Duplet for only the first shell, after that the octet is followed. So atoms are always trying to make 8 electron in the outermost orbit. So for that they may gain electron from the other or give their electron to the other, and that number is called as the valency of a particular element. Simple way, if I am talking about the sodium, sodium's formula is what? Na, or the symbol is a Na, and the electronic configuration is a 281. Now here in the outermost orbit, it requires 7 electron. It requires how many? 7, because octet it want to complete. So 8 minus 1, 7. 7 electrons are needed. Another possibility is what? The sodium will lose this 1 electron, and this will become the new electronic configuration. 2, 8. You can see now 8 is complete in the outermost orbit. So valency for sodium will be 1. What 1? Plus 1, because it's giving. It's a donor. So it will have a plus 1. Whichever will accept electron, they will have a negative valency. Like in this case, if I am taking a chlorine, electronic configuration 287, here it's taking 1 electron, because if it will take 1 electron, what will happen? The 7 will become 8. Okay, so valency for this it will be minus 1, because it's accepting 1 electron. So valency part is clear. Now here we will see the valency. The table I am writing over here and explaining to you. If you want, you can note it down in your textbook simultaneously. Now let's see here. They have given the molecular formula. First one they have taken as the HCl. You can see valency of the element is a 1. Electronic configuration of the element, hydrogen we have to write, that is 1. Number of valence electrons, that is 1. So here what we are going to have, 8 minus 1, which will give us 7. So it will be 8 minus 1, that is 7. After that, chlorine already they have completed. Neon, no compound. 0 is a valency of the element. Electronic configuration 2, 8. Number of valence electrons 8. So here what it will be? It will be 8 minus 8 equal to 0. Now here in the case of first one, that is hydrogen, we had what? 1 here, so 8 minus 1 we were doing, correct? But if you will see the formula, it is for x greater than or equal to 4. So here our x is what? 1. So directly we can write as a 1. If I am getting like here, I am getting 8 minus 8, then 0. Here 8 is more than 4. That's why this formula. Got it? So first what we did for the hydrogen, that will not be applicable. Applicable will be what? Directly valency. Now the next one is of fluorine, HF, number of the valency of the element. Fluorine's valency, how we can write? 1 because it's combining with a hydrogen. Then 2 comma 7. So number of electrons 7, and here 8 minus 7 equal to 1. Same way others you can complete. You try this, completed, and I will give you that this table again separately in a classroom, Google Classroom. Now we will go ahead for the part about the relationship we have seen. Then you can see here the table also, number of electron in the outermost shell for the hydrogen, carbon, sodium, chlorine and nitrogen they have given. So for hydrogen it is 1, for carbon it is 4, sodium 1, chlorine 7 and nitrogen is having 5. Okay, these are the number of electrons in the outermost shell. Next they have given is about the number of electrons they have, electronic configuration. Electronic configuration, if you want you can write it down. For this it will be 2 comma 1, 2 comma 4, 2, 8, 2, here 2 comma 6. So number of valence electron, here 1, here 4, here 2, here 6, and the valencies will be 1. For carbon it is 4, magnesium 2 and oxygen 2, because this is more than 4, so 8 minus 6, that will give us a 2. So this is about this one. And so in this session only this much. Next session we will talk about the isotopes and nuclear reactors.